Okay, example number 1, the angular displacement of the wheel is given by this equation here. Where theta is in radian and t is in seconds, determine the diameter of the wheel is 0.56 meter. So we have to determine the angle in degree at time t equal to 2.2 seconds and 4.8 seconds, and then the distance that the particle on the rim moves during that time interval, and then the average angular velocity in radian per second as well and in revolution per minute between 2.2 and 4.8 seconds, and lastly the instantaneous angular velocity at time equal to 3 seconds. Okay, alright, so firstly the information that we have is just the diameter as well as this equation lah. So the diameter can be used to find the radius, so which is so this is d over 2, which is the diameter is 0.56 divided by 2, which is equal to 0.28 meter. Okay, so that is the information. So now we can calculate at time at t equal to 2.2 seconds. We can just substitute lah. We substitute the value of t dalam this equation. So this is 2.2 square minus 2.2. So you should get the angular displacement to be equal to 22 radian. Okay, tapi sekarang ni dia mau in degree. So how do we convert radian to degree? We will times it with 180 degree divided by pi. Okay, aduh, kejap ah, my cat just switched off my laptop, so I can't really see the solution. Okay, so let me just calculate this using a calculator. So 22 times 180 divided by pi, we will get 1260. So 1261 degree lah jawapan dia. Okay, right, so untuk the second punya pula at t2 equal to 4.8 seconds, theta 2 is equal to 4.8 square minus 4.8. Then you should get the radian value to be 110 radian, and then convert this into degree times dengan 180 over pi, 180 over pi, so you should get 6303 degree. Okay, so that is question A. Now we should go to question B. I think I'm gonna do it on another paper. So for question B, we are going to apply the equation of arc length, which is S equal to R theta. Okay, so delta S is R delta theta lah, the change in the angular displacement. So this is R theta 2 minus theta 1. Substitute lah, 0.28, 110 minus 22. So you then get the distance that the particle moves during this 2.2 until 4.8 seconds to be equal to 24.6 meter. Okay, they minta distance tau, bukan angular displacement, so that's why we are using the S equal to R theta punya formula. Okay, so question C, the average angular velocity in radian per second and in revolution per minute between 2.2 and 4.8 seconds. So angular velocity, average angular velocity is given by this equation. Okay, and then we know that this is just basically theta 2 minus theta 1 over t2 minus t1. Okay, so we have all the values, so we can just directly use substitute into the equation here. 4.8 minus 2.2, so you should get the average angular velocity to be equal to 33.9 radian per second. Okay, now we have to convert it into revolution per minute. So if you want to convert it into revolution per minute, it's just basically 33.9, so this is radian over 1 second kan, per second dia tulis itu. So and then we have to darab dengan 1 revolution. 1 revolution, it is equal to 2 pi radian. And then 60 seconds per 1 minute. Okay, we want the value revolution per minute. Okay, so dapatlah jawapan equal to 324 revolution per minute. Boleh tulis macam tu juga. Okay, alright, so that is the solution for question C. And then lastly for question D, the instantaneous angular velocity. So we are gonna use the formula. Dia cakap at time equal to 3 seconds. So t will be equal to 3 seconds lah. Instantaneous angular velocity is d theta over dt. Okay, so this one we have to derive lah. Derive in terms of time untuk equation theta kita tu, which is equal to 5t square minus t. Kan? So yang ini we have to derive it in terms of time. So derivation is 2, 5t, 2 minus 1 minus 0. Sorry. T1, 1 pergi depan, so 1 lah. T tinggal 1 saja. So we have 10t minus 1. Okay, so dapat ini barulah boleh substitute at t equal to 3 seconds. So omega is 10, 3 minus 1. So you should get the omega to be equal to 29 radian per second. Right? So that is the solution for example number 1.